Hello, Mr. Ryan, right?
Yeah.
Okay, so let's take a look at this. What's this?
A tree. A binary tree.
Yeah, a binary tree.
Yeah.
Okay, so this is a binary tree. Anything special about this binary tree?
They have duplicate numbers.
Duplicate number. Yeah, they have different number. And
2 and 4.
okay, and
It's a triangle.
sorry, actually. What's so special about it? Anything?
When mirrored, it's the same.
Mirror. Okay, so another word, when we mirror it, yeah? Fold it, it's the same. So it's also
symmetrical. It's not symmetrical. It's not symmetrical because that 2 needs to be upside that 2 and that 3 doesn't have that rubber thing and that circle is the
Why is it not symmetrical? This is symmetrical.
No, it's not. Each sides have to be exactly the same. You need to flip the numbers around. You need to clean it so it's exactly.
So which bit is not symmetrical?
All of it.
Huh?
All of it.
That's symmetrical. You symmetrical, right?
No,
Like
No.
4, 4, 3, 3, 2, 2. That's the definition of symmetrical.
no, it's not. Symmetrical is something that is the same. Look, this is dirty. That's not. That one needs to be like this and like something like that. Just blah, blah.
Okay.
And that full one needs to be like that and that.
Okay, get your
little
point.
bigger than that one. That one not symmetrical because that has a little hump there.
Okay, I get your point. Okay, forget about the shapes. We are talking just the value, and that's it. Okay, so this is symmetrical. Okay. In early days, we talk about how to check this a tree if it's symmetrical using the recursion. Remember? Yeah. And today we're going to implement it using the just iterative approach. Okay.
Yeah.
We define check f function a and b. Right? A and b are two trees. Okay. So if a is none and b is none. Okay, we want to compare if these two trees A and B are symmetrical, right? So we given at the beginning we given these two trees. We want to check. This is actually a helper function to check if A and B are symmetrical. A tree and B tree are symmetrical. Okay, so it requires two parameters. But how do we apply this function to a finger tree? So we are passing these tree twice. Okay. So that's what it means. Okay. So A and B. If A is none, B is none, both are empty, then we return true, right? Return true. Empty tree is the same, symmetrical. If A is none or B is none, right? Then we return false. Am I right? At this point, A is none, B is not none, or A is not none, B is none, right? Because both trees are none is checked here. Both are empty, then we return true. If one of them is empty, we return false. Obviously, an empty tree and something is not symmetrical. Then we have to check, right? Return, and we can just return A dot value. It has to be equal to B dot value, right? So look, A dot value needs to be equals to B dot value, alright? I have another identical tree. This value needs to be the same as this value, right? Return A dot value equals B dot value, and F A dot left, we're looking for B dot right here, and F A dot right, B dot left. Okay, so we swap. So how do we interpret this? So if A dot left is this bit, and B dot right is this bit. Right? So this bit and this bit needs to be symmetrical, and then this bit and then this bit needs to be symmetrical. Right? Does it make sense? Okay, look at this. This is A, this is B. Okay. So we need to call this recursive function. If A is none, B is none, both trees are empty, then obviously it's a symmetrical, right? If one of them is empty, we return false, right? Alright, so we want to check if these two trees are symmetrical. Basically, we want to check this tree is symmetrical, so we duplicate it, right? So in A dot value needs to be equals to B dot value. Also, the A dot left is this bit. Needs to be symmetrical to this bit, right? B dot right, right? Look, 2, 3, 4, 2, 4, 3 needs to be symmetrical. A dot right is this bit, needs to be symmetrical to B dot left, right? This is what it is. And then you just return F A A. F root, okay? Root. Okay, that's what it is. Okay, so look at this one. If we don't swap around, what happens? Look, I'm saying that if we swap A dot left, B dot right, A dot right, B dot left, right? This is to check if the tree is symmetrical. But if I don't swap around, then what does it do? One question for you. If I'm just saying return A dot value equal B dot value, and F A dot left, B dot left, and F A dot right, B dot right, what does it do? If I change it to F A dot left, B dot left, and F A dot right, B dot right, so what does it do?
So the left and the right tree would be the same.
Exactly, that's true. If I'm changing to A dot left, B dot left, A dot right, B dot left, we're just checking if the two trees are the same, right? Yeah, okay. Okay, so that's very good. Actually, we talk about that. When we talk about recursion to check if two trees are identical, we use the iterative, right? And it's the same. So I can implement that using the iterative, and that will be, okay? That will be. So let me erase this bit.
A young.
So define F, A, B. Let's compare if those trees are identical, right? So we use a queue or stack, right? We use a queue, DQ. We can perform this using depth search, breadth search, right? Level by level. 1, 2, 3. And then we want to check if two trees are the same. We just perform this both level by level, okay? DQ. And then at the beginning we push a tuple A and B. Right? And then while there is an element in the queue, we get it AA BB equals Q dot top left. Okay, we're taking out from the left hand side. We're taking out the element from the left hand side. Then I was almost using this to erase it. Okay. And then right, so we just put this here, right? Copy here. If AA, actually we need to change AA, right? So if AA is none and BB is none, AA is none and BB is none, we need to continue, right? If we need to continue. Continue instead of return, right? This is recursion with returning, but for the breadth search, depth search, we need to continue to checking the next, right? So if AA is none, what's if?
Else if.
Or yes, BB is none. Then return false, right? Because if one of the node is empty, one of the node is not, then it's not a identical tree, right? Else, what do we do with it? Else, now we need to check. Actually, we else if, okay, we still have to check if AA dot value is not equal to BB dot value, then we return false, right? We found that one of the nodes do not match each other. If this here is 1, here is 2, it's not the same. Then else, we need to push it back to the queue, right? Q dot append. Okay, append what? A dot left, B dot left, Q dot append, A dot right. Come on, B dot right. So if you want to make it checking if the tree is symmetrical, which line of code we need to check? This is just iterative. This is the iterative version of the left hand side, right? Actually, there's something needs to be changed to match exactly the same. So which line of code? Yeah, so A dot left, B
Dot right.
B dot right, and A dot right, B
Dot left.
left. Okay, so look, we're done. A dot left, B dot left, that's checking if the trees are the same, yeah? We have to check the left trees are the same, right trees are the same, right? This is to check if two trees are the same. To check if a tree is symmetrical, we just have to check if the left tree is symmetrical to the right tree, and the right tree is symmetrical to the left tree. That's the symmetrical, right?
Yeah.
Yeah? Okay, so this is the iterative. Look, we are using the DQ here. Can we change it to stack?
Yeah.
Can we change the stack?
Yeah.
Yes, because the order of checking the nodes do not matter, right? Here, this is 2, 3, right? So 1, 2, 3, 4, 5, 6, 7, right? we want to check if two trees are the same. Right? Two trees are the same. The order of checking each node do not matter, right? Does it make sense?
Yeah.
I can check this. I can check level by level. Look, I can check level by level. Yeah, using buffer search. Or I can check it within the depth search. Am I right? It doesn't matter. It doesn't matter, right? The
Yeah.
order of visiting the node do not matter.
Yeah.
Okay. So this is the iterative and recursion. We visited the two problems. So one is checking if two trees are the same. Two trees are the same, right? Or two tree. If we check the tree is symmetrical, right? Symmetrical. So when we talk about checking the tree is symmetrical, we also talk about another method. 1, 2, 2, 3, 4, 4, 5, right? Or 4, 3. So we also talk about how do we do it? This is a tree, right? We invert it. We invert it, and then the left tree become the right tree. The right tree become the left tree. So the left tree become the right tree. Yeah. We talk about that inverting the tree. So it become this. Right? This is the original tree, and then we invert it. Right? We got this tree, and then we just have to check this tree if it's the same as this one. It's the same. It's symmetrical, right? This is ideal, right? Do you still remember how do we invert the tree? I'm using the recursion as well. Left equals invert root dot left, right? Right equals invert root dot right, and then we just say root dot left equals right, right? The left tree we assign it to the right, and root dot right equals left, and then return root. And then if not root, then we just return, right?
Yes.
Just return.
Yes.
Eh?
Yes.
So root dot left. I want to invert this tree. So left needs to be invert version of the right tree, and the right will be invert version of the tree, and then we keep recursively doing that. Okay. This is actually the interview question of Google. Okay. Yeah. Just a few lines of code using recursion. Okay.
Okay.
And yeah, so you see how we do it, right? So it's quite similar using recursion and using the iterative. We can use a queue or stack, it doesn't matter. Okay. Stack, we just using a list to do it, and it's the same. Okay. And so what have you learned today?
Socks.
What have you learned today? Come on.
About a binary tree symmetrical.
We want to find out if a binary tree is symmetrical. So how can we do it?
We can use recursion.
Or we can use the iterative.
Iterative.
Yeah, we talked about these a long time ago in the early days, maybe in 63, 64 days. And
You should
we
see
also talk about how
You should see day 40.
Okay, day
Very
40 is
funny.
funny. The time complexity, O(n). The space complexity, O height, OH, okay? OH, in the worst case, H is N. Okay, so can you tell me in what case is H equals N?
It's like a line,
A line.
only with one kid.
Oh, yeah, it could be this way, or it could be this way, or it could be, zigzag. As long as each kid has only one kid, the number of nodes equals the height. Okay?
Yeah.
Okay. Okay. That's it for today. Bye bye.
Bye.
Bye bye.